So we're going to take these ideas about potentials and return and apply it to kind of the idea of constructing cells. We're going to do that just by looking at an example of construct an electrochemical cell based off the half reactions of Al3+ to Al and SN4+ to SN2+. All right, so what is it? We want to construct an electrochemical cell. What does that even mean? So what we want to end up with is a cell notation description. Really, that would be kind of the bare minimum of just kind of describing what's the anode, what's the cathode in terms of reaction, what are literally the materials I'm going to use. And we're going to go ahead and draw a picture of it as well. So we can go ahead and draw a picture, draw a diagram. It doesn't need to be fancy, just kind of a schematic, if you will, as to like how I would make it. So it's kind of almost like a blueprint for constructing. We're not actually going to build something. I'm not gonna build it for you on my dresser here. Instead, I'm just gonna draw a photo of what, not draw a photo, draw a picture, schematic diagram kind of thing of what we're dealing with. So first thing is the chemistry. I always want to start at the chemistry, figure out what my half reactions are. So Al3+ becoming Al, 3 electrons there. And then I have SN4+ becoming SN2+, and I have 2 electrons there. So I need to know which one of these is going to be the reduction, which one's going to be oxidation. So go to my half reactions. Right, I return to my half reactions. The tin4 to tin2 is 0.15. Not a negative, just 0.15 volts. The aluminum, negative 1.66. So this is lower. So that means this is going to reverse, which means it's going to be oxidation. It also means it's going to be the anode. So that means this is going to be reduction over here. Just going to stay. So we're going to use this for the cathode. This is going to be the reaction at my cathode. So I'm going to need to go through the parts of the cell that I would need. I'm going to need the actual electrode, the actual piece of metal here. So what I want to look at is, well, what materials are in there? Is there any solid? Yeah, that's an ion. That's a solid. Aluminum is a metal. I'm just going to use that. I might as well use aluminum. And for my electrolyte, do I have any ions? Well, yeah, I got the aluminum ion, so I'm good there. But it needs to be in a salt. So what I'm going to do is I'm going to pair it with sulfate. And that's going to be a salt. I'm going to dissolve it in water. I'll make it into a conducting electrolyte. Let's take a look at the cathode. So tin is a metal, but we'll note this is tin4+, that's an aqueous cation, tin2+, that's an aqueous cation. So that's not going to work. I can't put tin in there because it would probably react with either of these. Instead, I need something that is, I need to use inactive. And we're going to go big money. We're going to use platinum. So whenever I have these ions, that's where I need to be using my inactive electrode, because these are just going to be out in the electrolyte. I need just a piece of metal that won't react. Platinum is very unreactive. So then for the electrolyte, I need both the tin2+ and the tin4+. And so what I'm going to do is I'm going to dissolve both of them. Again, they're cations, so they need to be paired up. So I'm going to do this with sulfate, and I'm going to do this with sulfate. So I'm just going to dissolve both of them with sulfate. You can use any non-reactive cation, anion, sorry. So sulfate is just a really good choice just because it is very unreactive when it comes to redox chemistry, which you really want to happen. Same way we're using platinum, which is non-reactive. We want only the tin to be reacting in this half cell, or this half reaction, not the tin. So, not the sulfate, not the anion. So good. So what we can do is we've got all the parts. We can do it like write out like a cell notation. So we know we start with the anode, and we start with the electrode of the anode. So that is going to be aluminum solid, vertical line, Al2, SO4, 3, aqueous. Then we can write vertical lines for our salt bridge. Then we need our cathode electrolyte. And so we're actually going to go ahead and write both of these things. So we can write the SN, SO42 aqueous, and the SN, SO4 aqueous. You just put a comma in between them. The vertical lines imply you're talking about electrolyte or electrode change. So we do put the platinum in there because you're really kind of given a recipe. You're kind of trying to schematic it out. So we can write it, these we've included the salts explicitly. We can also write it a little bit differently. We can say aluminum, we can say Al3 plus aqueous, vertical lines, SN4 plus aqueous. We still use a comma, 2 plus aqueous, vertical line, and then platinum. So these are just aqueous that I have here. Just write out the ions because that's what really matters in solution. This is kind of a bit more instructive. You're saying what salt you're going to use. You're just saying get the ions dissolved in solution. And finally, the last way we could change it is we could say Al solid, vertical line, Al3 plus aqueous 1.0 molar. You can specify that concentration. And we would just use, because we're looking at, if we're doing under standard conditions where everything is 1 molar, so you can specify that in there. We also never specified our salt bridge. We're just using vertical lines for our salt bridge. So that's my cell notation. Now I thought I want to do some drawing. Okay, so I'm going to actually draw out the electrochemical cell. And so what I'm going to do is I'm just going to start with like basically draw like beakers. And you'll see the drawings that I'm going to make are not going to be gorgeous. I'm not expecting them to be gorgeous when you need to draw. So got some liquid in my beaker. And now each cell is going to have an electrode in it. And I'm going to go ahead and say that this is the anode and this is the cathode. I don't necessarily need to say those things, but I'm going to go ahead and say it. So anode is, which one's anode? Aluminum. So we said the electrode was going to be aluminum solid. So this is just a piece of aluminum. The solution is just Al2, SO4, 3. And I made it 1.0 molar if we want it to be that. We can specify that. The cathode, platinum was in there, and then my electrolyte was the tin, SnSO4, and the SnSO4 2. I'm putting that the wrong way. And then we connect them with a wire. We know the electrons are going to flow this direction. And so that's great. We got our electrons flowing. There's one final thing we don't want to forget. That's our salt bridge. Just wrote it as vertical lines in each of our cell notations. When you're drawing your cells, you always need to get salt bridge. And I'm going to use sodium sulfate. Sulfate's a popular choice. If you want to call it aqueous, you can. Kind of, it would be generally implied, but never a bad idea. Go ahead and say the phase that it's sodium sulfate aqueous. So, you know, you may have thought, man, this drawing's going kind of well on the beakers. I was kind of proud of it too, and then the wheels fell off. And it's okay. These don't need to look, you know, super fancy, obviously, or colorful or anything like that. But you do want to have everything labeled to what it would kind of look like. We've seen, you know, we have these schematics in real life. It would never be this pretty. But it's more of just kind of being able to conceptualize how you would put all these pieces together, what pieces you need to specify, and how they are all going to fit together.
Participation 1111, question 2. Construct an electrochemical cell based off of the half reactions of aluminum 3 plus to aluminum and SN4 plus to SN2 plus. What is E cell naught for this cell? This is the second question on participation 1111, due Tuesday, November 11th at 11:59 p.m. over on Blackboard. Link to the assignment is right below the links to these videos. Again, construct an electrochemical cell based off the aluminum and tin half reactions. You might have already done that. What is the E cell naught for this cell? Just looking for E cell naught, the value of E cell naught. You maybe already did some of this. Okay, that was our second participation question. We are now over halfway through this set of videos. Might find some more questions in the back half. Have to watch the videos and find out. I'll see you there.